example I would have liked to have would have been peatlands, carbon, climate change, and the IPCC. The reason is because before I start talking about the Intergovernmental Panel on Climate Change and what I will talk about is the wetland supplement, which is the most important piece of document published lately, I need to introduce it to yourself because I think it's a very important subject, which is often not, which is often overlooked because you can't see carbon. And that's a big problem. I've been fighting for the last 20 years in Ireland to make people understand carbon is very important, but it is very difficult to explain the science. So I will, and I'm sorry for those who might know already about that, but I want really to make sure the message today is put across, especially about peatlands, but I will talk about other wetlands, the carbon and the science behind the carbon in the peat soils. Okay, so bear with me. I'm not going to talk straight away about IPCC, but just bear with me. Okay. So the reason is why are peatlands important for scientists, and this is all the reason why I'm here talking about the Intergovernmental Panel on Climate Change. Right? It's because not in Ireland, not in Europe, but around the planet, around the world, scientists have been studying peatlands and getting worried. Why? Well, this is actually a book that came out in 2013, and I was very intrigued because it was the biggest question in science, and I always wanted to be an astrophysicist. I love studying the universe, I love reading about the universe, and I thought that the best scientists in the world, that's the only thing they want to understand the universe. So, fair enough, question one was, what is the universe made of? But I was very surprised to see question 9. That's the biggest question scientists should ask themselves, right? Question 9 was, where do we put all the carbon? And right at the bottom there, this is all about climate change at the beginning, we have to protect natural, long-lasting stores of carbon, such as forests and peat bogs, and start making energy in a way that doesn't belch out even more. That's one of the most important questions scientists need to ask in the next century. I don't think people have realized that. I don't think people have realized this is how important it's become. Okay? So, now, it's my job to make you understand why. This is going to be published in the very first peatland strategy, the National Peatland Strategy in Ireland, which is going to be published very soon now. It's been approved by Cabinet. We need to understand why peatlands are a special natural resource. And this is trying to explain all the ecosystem services. And all morning I've been watching those, and you know why we protect our wetlands. And these are all very visible. But right in the middle of it, there is one here, carbon sequestration, which is not visible. It's not here. Well, actually it is. It's everywhere here. I see carbon everywhere here. This is made of carbon. This is made of carbon. Everything here is made of carbon. Okay? It's just we can't really see it. So people find it hard to understand that this is one of the fundamental functions of a peatland. Now, I don't have time to talk about this diagram, but this would be very useful for anybody who wants to show how wetlands, any wetland, and peatland in particular, the benefits and the ecosystem services. I want to go back to carbon, okay? Why is carbon everywhere, in all living things, okay? And that's where things get complicated. People switch off. Like, no, it doesn't look pretty like this butterfly or whatever. It's made of carbon, okay? This whole carbon was made billions of years ago when stars died, okay? It came to here, and through magic, really, and I'm not going to go into this, but we are all made of carbon. And through plant photosynthesis, that's plants that are taking carbon from the air, they're bringing it into being a plant. And that's the first thing you see carbon through plants, through animals. When those die, then the carbon is usually released back to a gas phase. That happens in all things everywhere in the world except in wetlands. Because in peatlands and in wetlands, oxygen is not there, it's wet. So it cannot decompose the carbon back into its gas phase. So it stays into the vegetation, into the peat, okay? Peat is 40 to 60% pure carbon, okay? And that's That's how I see it, and that's how I hope people will see it now. So just a bit of chemistry. I'm not going to give you a lecture, but just so that you remember, okay, the carbon you see in that plant, in that butterfly, that's the solid phase. Then it easily can go back into the gaseous phase, in the atmosphere. It can go back as CO2, what we breathe out, CO2, or as methane, okay? That's the main gas I want you to remember today, CO2 and methane, and that's the carbon. What I want you to understand is this carbon in CO2 and methane that is in the atmosphere comes originally, can come to the solid, from the solid phase, which is the vegetation, the peat, the animals, us, okay? So why is carbon so important? These gases I've been mentioning, carbon dioxide and methane, they're the two hot ones. It's because in the atmosphere they trap heat, which is great. We wouldn't be here if it wasn't there. We wouldn't be able to live because it would be freezing. So they trap heat, and that's fine. For millions, billions of years, the planet has been doing fine with that ambient temperature. And those are called natural greenhouse gases because they have a natural greenhouse effect. However, over the last 200 years, it's been now proven at 99.999% that anthropogenic activity have led to a dramatic increase of CO2 in the atmosphere and methane. That's the one we forget about a lot of the time. Methane, remember that. That resulted in increased global temperature, and what we are not going to discuss global warming, but basically that's one of the implications. Where has this CO2 and methane come from? Now, naturally, CO2 comes from the world of decomposition. Methane comes from natural wetlands. So the thing is to remember here, fossil fuels, deforestation, agriculture is the ones we usually look at. Drainage of peatland now has come as to one of the biggest reasons in the last 200 years why we have increased methane and CO2 in the atmosphere. Okay, so to understand that, bring back carbon to the peat. Peat exists, as I explained, because of something quite phenomenal in the world of nature. Okay? Nature is about recycling everything. It's been doing that for billions of years. So when something dies, it decomposes and it returns as a gas, and then it's being used by something else later on. In wetland condition, this doesn't happen. It's what I call a spectacular failure. And it's spectacular because it doesn't happen anywhere else in the world. It's the only place that this phenomenon happens. So, peat is formed because of extremely slow decomposition of organic matter, and this carbon that I have in my hand there, that is carbon. If you had to picture it now, that's carbon in my hand there. Okay? So of course it's special. Peat is special, it's full of carbon, and carbon can burn. That's why we all living things are full of carbon. It's an energy source. That's why we have carbon. Okay? So, just to remind people, peat is actually like coal at its primary stage. Okay? Coal that we extract now was peat at some point in geological time. Okay? So, in terms of calorific value, it's not as good, obviously, as coal, because the more you keep longer, the more calorific efficient it is. So when you burn the same amount of peat compared to coal and gas, you really are not very efficient at all. Okay? So this is just in comparison. Peat emits so much CO2. What does it mean? It doesn't use the carbon to produce heat. It re-emits the carbon. Okay? So when you burn peat, you think you're producing energy. You think you're producing heat. But what you do is, most of it is just released in the atmosphere. You're heating the atmosphere, not what you want. So in terms of emitter, it's the highest fuel in terms of CO2 emission. Okay, so Chris mentioned this morning, rightly so, peatlands. Meter for meter, they store more carbon than any other terrestrial ecosystem. And peatlands, especially tropical peatlands, here, contain so much carbon, that's where the focus of the attention at the moment politically is. We hadn't realized that. We hadn't realized that most of our carbon is actually done there in Indonesia, and it's in smoke at the moment. So, I'm not going to, don't worry about the details, just remember, peatlands, there's a lot of carbon in it. As it happens in Ireland, we have a lot of peatlands, but what we don't see is what's below those peatlands, and we have an awful lot of peat and carbon below waiting here. So overall, we estimated 3/4 of all our terrestrial carbon in Ireland is stored in peatland. Still, we have lost an awful lot, but we still have that much, okay? And as Chris said this morning, you know, this is a very critical source. Okay. Quickly, I want you to understand again why is that carbon. I know I might be repetitive here, but this is my chance. I teach this to students in university, and they're like, yeah, we don't understand what carbon is. And then I meet them 10 years later, and like, no, I still actually, you know what, I don't know how carbon got in there. Okay, so I'll be clear. See, you've seen those CO2 molecules going into the bog there? For the last 11,000 years, since the last ice age in Ireland, Irish peatlands have been taking in CO2 from the atmosphere. Literally imagine molecules of CO2 up there being used by the plants, and without, mind you, there was nobody living in Ireland at the time. You know, the first Mesolithic people 8,000 years ago might have seen a few boggy areas, and the bogs were happily taking in carbon and growing and storing it. They stored lovely things at the same time, bog butter, bog bodies, and they stored it and they kept it in their layers. How do they do that? So briefly, this is important for the next bit, so stay awake. CO2 comes in from the atmosphere through the plant, and that top part of the bog there is what we call the aerobic. There's oxygen in there, so there's a little bit of decomposition. And when there's decomposition, CO2 obviously is emitted. However, here, below the water table, this is where there's water. In the water there isn't decomposition. There is only anaerobic decay. And these are bacteria. They don't need the oxygen. They try to decompose slowly things, but they emit methane. Okay? So this is roughly how the gases are circulating. Okay, so the questions we were wondering were, okay, so gas come in, gas come out. What's the balance? I mean, what are we at? So gas come in, okay, gas come out. Then we have a little bit of dissolved organic carbon in the water. We see it's a wetland. Water flows, it goes into rivers. So you lose a bit of carbon there. You lose your carbon here. So overall, what you do is simple. You measure how much carbon comes in. You can do that. Then you measure how much methane and CO2 comes out, and how much carbon here comes out. And then you should have what we call a carbon balance. Okay? Simple. Your carbon balance is the sink, as in it's a carbon sink, when carbon is taken up by the plants, more than what is released through decomposition, and so on and so on, sorry, anaerobic decomposition and fluvial. Okay? Most natural, and that's why they are there, natural and undrained peatland are carbon sink. Otherwise, they wouldn't have accumulated. Okay? That doesn't say they didn't emit any. Okay? They do emit gases, especially methane. They do emit not a lot of methane. But they sequester so much of the carbon dioxide stuff that the balance is positive. It's a sink. It's a carbon source, however, if there is more carbon obviously released back to the atmosphere than is taken up by the plants. Now, of course, if you don't have the plants like in a peatland extraction field, you're definitely on the negative there. You have absolutely no way of sequestering carbon. You might as well forget it. What you're doing is just pumping it out. But even a part of a bog where you look at it and you say, okay, there's plants there, there's lovely heather. Yeah, there might be lovely heather, but because it's drained, you have about 2 or 3 meters of dried peat just going back into the atmosphere on its own. And you might not see it because over a year it might be just a few grams. But then accumulation, you know, year after year, that bog is disappearing. Quickly, because I want to explain that so that it's not too remote. How do we measure it, this whole thing? we've been fortunate enough in Ireland lately to have got funding from the EPA, for instance, and Bonamona and NPWS to look at sites to understand what's going on, because we have so many peatlands in Ireland. They're so diverse. So, we didn't know. We didn't know what was the carbon balance of an Irish peatland, and that was very sad when we went to conferences, because in Finland they knew it, in Canada they knew it, and we didn't know. So we had to come up with some figures. So this is how we measure it briefly. So you go to the field, literally, it's field work based. You go to the field, you measure it. Differently depending on, obviously, the type of peatland you have. If you have vast expanses of natural peatland, you can use a tower up there. Or if you have more small communities here, this is a monoblock, by the way, that they restored. You want to understand maybe what's best for the bog, for the carbon sequestration, what best vegetation composition is best for best carbon sequestration. Sorry. So we go out and we measure it, and over the years, obviously, you need to have many sites. You need to have many years, because every year there's different weather conditions. So you can have a dry year, you can have a wet year. But overall, you get ideas. You get an idea. And what I call an idea is what we call a range. You get a range of what a bog should be. And what we found out is a bog is a natural bog. It's always a source of methane, a natural undrained, always a source of DOC. And depending on the year, it could be a source or a sink of CO2. In Ireland, we found that we had a few studies, Clara and the Schlitt-Bloom. We find that the carbon balance of natural Irish bog is very variable, but in general, it's a small sink. Okay? So we're happy with that figure there in red. It coincides with other international figures. The problem was not that. The problem was that we have so little of those that we're not too worried about the natural Irish bog and how variable it can be. But it's the other bogs, how much carbon they're emitting. So, take this bog, for instance. You have a very limited area of the bog, which is the central bog, which is active. That's the only place where the carbon is actively sequestered. The rest of the site, not only here, obviously the peat is gone, here it's drained, but even on the outskirts here, where the drainage here has an impact on the bog here, and that is not sequestering carbon anymore. On top of that, of course, you have the burning of the peat. The actual peat is burned, so the carbon is being returned. So what we've done is, peat has been used in Ireland for many things. So we have loads of types of peatland land use categories. Okay? This is a terminology we use for different countries so that we know what we're talking about. So we have natural peatlands, some that are used for agriculture, for forestry. All those land use categories are very important to report, and I'm going to talk about that in a minute. But what we needed to know, basically, in Ireland is where there are bogs where an asset or a boon or have we got a problem with our bogs, basically. So natural peatlands, we found they are either a small sink or a small source. Rough grazing, where there's rough grazing and poor drainage, we found in parts that there were probably small source, but some parts probably small sink. And I talked to you a bit about that work I've done on very wet grazing ground, for instance, in the west of Ireland, which actually are small sinks. If it's any drained and under pasture, again there, because you have a lot of quite productive grassland, you could have small sink to large source. Drain under forest, variable. This is definitely a large source, what we come up with. So on anything that is cut bogs is a large source. Turf cutting, industrial extraction, all those obviously large source. After uses of cut away, so that's basically once you have extracted your peat, what you do with it can have an impact on your carbon balance. If it's a mature forest, it could be a small sink, but we are unsure about that. Now, that's where things get interesting in the last 10 years. We've been looking at rewetted bogs. And mostly this was on the Bonamona, trying to see whether, when you finish harvesting a bog, when you rehabilitate it or restore it, have you restored the carbon function? And that's what we've been trying to understand. And overall, we are quite optimistic to say that rewetted cutover and cutaways are small to medium sink. Okay? So that would be positive in terms of restoring the carbon function. The problem in Ireland is, okay, this is fine, we have a small idea now well, small idea, it's variable, of our land use category in terms of peatlands. So you go to a place like that, in County Mayo, and you see lots of land use categories here. You see a wind farm in the background, cutover, cutaway, a forestry plantation, a conservation area, you see the gas pipe was there as well, being built. So you see some grassland, some rough grazing. And that's where the problem began in Ireland, is that how do you report this now? Okay, you've got 1,000 hectares there of so many things going on in your peatland. So what I put is in red, it's all the carbon sources, and in green, the carbon sink. Okay? So what we found is shallow drain grassland here could actually be a small sink. Obviously, a conservation area is a small sink. Forestry plantation at that point is a sink as well. However, other land uses are obviously large sources. So the problem now, the question for Ireland was, putting all together, is this, what have we got? We got a source or a sink, and how do we report it then? And that's where the problem was encountered when the UNFCCC, United Nations Framework Convention on Climate Change, started to ask parties with the Kyoto Protocol to report their emissions on different categories, land use categories. So, a little word on, these are abbreviations I use a lot, so I realize not everybody will actually know what they are. So just to remind you, the UNFCCC entered into force in 1994, and nearly all countries have signed to it now, and it's basically trying to help to prevent dangerous human interference with the climate system. And you would have heard about the Kyoto Protocol. You would have then, you might have heard why then, what in terms of country, what do we have to do? We have to report our greenhouse gas emissions under different categories. And typically, these are energy, agriculture, land use change, and forestry. So, since this is to do with human-induced greenhouse gas emissions, we only report what human-induced activities we do. So greenhouse gas emissions from natural bogs are not reported, okay? Just so that you know. So there was a growing understanding, though, that until recently, not only natural bogs were not reported, but drain bogs were not reported that well either. In fact, the worst thing was in the last Kyoto Protocol, there was a category called wetlands, and believe me or not, but that category was peat extraction land. That was the category. It was called wetland, and it was only what was reported was peat extraction land. So obviously there was an understanding of the climate value of wetlands, and in particular peatlands, which grew a lot from the Wetlands International. We heard about Ramsar doing obviously great work for protection of wetlands. Wetlands International is another umbrella, and they really are lobbying all the governments to have this included in the UNFCCC. And because of their good lobbying, we have now a new activity since 2011 called Wetland Drainage and Rewetting category. In this, under this category, countries can elect to report. They don't have to. They have to report all the others, but this one, they have to elect to report to WDR. Ireland so far has not elected to report it. The UK have. Strangely, we're very surprised, but that's a big step forward they did, because that means if they elected to report that, that means they are serious about protecting and rewetting their peatlands. We're talking about there's no legal framework to protect our wetlands. This is not a legal framework. This is money. This is our carbon emissions. So they know that they can probably report. You have to report your drain bogs as well as your rewetted bogs. You can't just report the rewetted or this is the drain. So you have to have both. So the problem I see though is okay, I'll come to talk to the IPCC, which is what I've been talking about. With Ireland, I think the UK have made a big step forward in understanding the value of peatlands for the carbon, and that would be really the biggest the tools to help protect peatlands. The problem is you need to know what you have before you report it, and that's our problem in Ireland. Ireland can't elect because simply we don't know where our drain bogs, our rewetted bogs. Rewetted bogs actually we know where they are, mostly old bone and motor bogs. But we need to have very good activity data, and that we don't have. So finally, the IPCC. Okay, basically the Kyoto Protocol works because the IPCC helps countries to correctly report their emissions. Okay, so far a country like Ireland, so it's the EPA which is obliged every year to report under the UNFCCC and under the IPCC all the greenhouse gas emissions under categories, and you follow guidelines which are those GPGs. Now, the guidelines were first written in 2006. And it was a challenge then, even then at the time, why things were not supposed to be reported. For instance, the category called wetlands, it was only peat extraction field. And never mind that, only bone ones were reported, not the small producers. So the rewetted peatlands were not reported because of lack of scientific studies. What happened is that around the world, there was an increased number of studies showing that, rewetted peatlands are the low-hanging fruit there. By just rewetting a bog, you could first stop the emissions, but even return back carbon as a sink. So that quickly took a turn for the IPCC to say, right, we need to develop guidelines. And in 2011, then the decision was taken to create a wetland supplement. Purely for wetlands. Imagine, that was the first thing. Out of all categories, forestry, agriculture, they decided to concentrate on wetlands. They called in experts from different countries. So the EPA were in charge of finding experts in Ireland, and myself and two others, David Wilson and Ken Byrne, were lead author for this wetland supplement. So what we did is we met in different countries with other experts. We gathered all the literature, all the studies, published, unpublished, and that meant stuff like Russian studies, which we had to translate, make sure it was correct, checking basically all the literature, all the data that we have, and can we come up with a consensus from all the countries to say a drain peatland, which is used either for agriculture or used for forestry, emits X and Y carbon. Rewetted ones can have a potential sink of X and Y carbon. So this wetland supplement was published last year, and what it does is now all the countries that are signatory of the UNFCCC have to use this wetland supplement. So this was very important. This was quietly, this didn't receive much attention, but in the world of wetlands, this is what everybody was hoping for, and this is what's going to be moving governments in doing things. So I've been talking about peatlands, and I know there's people in the audience who are interested in other wetlands, and other wetlands are included in this, yeah. And I just talk about, for instance, the coastal wetlands, which we call the blue carbon. Big push there to protect the coastal wetlands because they're for the future. I think they're going to be very important for carbon sinks as well. So just to finish off, this is what it looks like. It's a table, and it tells you that when you rewet a bog, which is we're in the temperate zone. If it's a cool bog, it's a carbon sink. The problem is if it's a rich bog, it's a source. And the countries have to report that. And that's where we come in, is that we want to study more bogs, especially the fens, because the fens are the problem in temperate zone, that we think the fens now are doomed, basically. Now that's been a sort of a feeling we've had for a long time in terms of carbon, but we haven't found yet a fen, a rewetted fen, that is taking carbon anymore. And the reason is the climate is not there for it anymore. That's unfortunate. So we need to keep an eye on those and understand what's going on, so that maybe we can protect what we have left, because from a work perspective, we have a problem with our fens, actually. So, finally, because I don't have much time, to complete, and for today, I think about wise use, which I don't like the terminology, but I think this has been a tool to help promoting wise use, and not only of peatlands, but of wetlands, all wetlands, but also organic soils, which people tend to ignore, is that all those peat soils on the grassland, all over the west of Ireland and all that, it's really important. And finally, I would say Ireland, I think, should follow the suit with the UK. I think rewetting peatlands is the next best thing that we can do, and hopefully with the rice bogs first, rice-borne national plan, and then the blanket bog, we can hopefully then push Ireland. And Ireland is in a good place to show that we can actually report, we can actually show that, you know what, we have drained bogs, but now we can rewet them and take credit for it. Okay, that's me. Sorry, I was a bit long.